So in this chapter we are examining solutions and colloids. So a majority of the chapter is for solutions, and we start off by just again defining what a solution is. So it is a homogeneous mixture of two or more pure substances. So pure substances can be elements, and they can also be compounds. Mixtures, on the other hand, will be mixtures of either both of these or a combination of these, and so on. So in this picture below, actually, we see potassium dichromate being mixed with water, and then it ends up forming a homogeneous orange solution. So you know that I love me some SpongeBob, and what I want you to think of in terms of solutions in SpongeBob is whenever SpongeBob and Patrick go visit Sandy, and then they finally sort everything out, and then she tries to give them tea like in a glass, but then obviously they can't drink it, so then she just puts the tea bag into their little water helmets directly, and then it you can see it absorbing into their water. So that's what solutions are. They form a uniform solution where you can't see the solute. In this case it would be the tea, dispersing uniformly into the solvent, so the water. The ability of substances to form solutions depends on two things, so whether they're going to mix naturally and also IMFs. So some common types of solutions, and I also want to point out that solutions can exist in all three physical states, but some common types are, for example, air, and this is a gas solution where both the solvent and the solute are gas. So air is made up of a lot of oxygen and nitrogen. Next we have liquid. So for example, you can have all three different states in liquid as your solvent. So club soda, anything like fizzy, has CO2. So any soda, any drink, Dr. Pepper, Coke, whatever, any alcoholic drink will be a liquid solution. So vodka, for example, ethanol and water. And then seawater has salt, so that's originally a solid and then it's dissolved into water. Something which is more unlikely for you to think of a solid and a solid solution would be like an alloy composed of two different types of metal. So some general traits of solutions: they are homogeneous, uniform, that's all it means. The physical state of the solution will typically be the same as a solvent. It's in a larger quantity, so that makes sense. The dissolved solute will not settle out, so it should stay in solution. The components of the solution will be dispersed, but they are a mixture of their own separate molecules, atoms, ions. So what is this natural tendency towards mixing that solutions have? So for example, whenever you mix gases, this is a spontaneous process. What does spontaneous mean? And before we talk about that, I actually want to mention that this will come up later on in the semester again, and you will learn more details about this. But for now, just know that a spontaneous process will occur under specific conditions, but it will occur without requiring energy from an external source. So the way you can think of that is you don't have to put in any sort of energy, whether it be heat, whatever it is. So it happens on its own. Mixing causes more randomness, and this is something that the universe likes. So it increases specifically a thermodynamic quantity, which again has to do with spontaneous processes, called entropy. You're again going to hear this later on in the semester, but just know that randomness is entropy. The universe likes it. Whenever you have these solutions of gas, for example, helium and argon, whenever you open, for example, a valve to let them mix, they go completely into random places. They mix completely. This is favored because of that increase in entropy. Another thing we also mentioned again was IMFs. So before we get into this I do want to give a little short review on IMFs. So we learned about the 3 different IMFs. These are those right here. We have LDFs, dipole-dipole, and then hydrogen bonds, right? These are all IMFs. IMFs are forces of attraction. They are not bonds. I know it's confusing because hydrogen bonds, the way it's named, it's not an actual bond between atoms. These are attractions between molecules. So think of it like it's more meta, right? This is occurring between little units called molecules, not within actual bonds, okay? So don't confuse that for bonds. So that's why this little diagram shows you how these are the weakest up here compared to the dipole-dipole, then hydrogen bonds, and then covalent, and then ionic. These are bonds between atoms, okay? So those are intramolecular, versus intermolecular are between 2 different molecules. Bonds are within one molecule between 2 different atoms. So IMFs are present in solutions as solute-solute interactions, solvent-solvent interactions, and solvent-solute interactions. So we have a bunch of different IMFs that can occur, and also this is just to recap the different types of IMFs. So if you need a refresher on that, just go back to that video from that previous chapter. So whenever solutions form, we can think of it as a stepwise process. So what do we mean by this? So we have a solute. We start off with a solute and a solvent. This is before we mix. And whenever this happens, there are things that you have to overcome, like IMFs. So we have the IMFs that are between solutes themselves and then solvent molecules themselves, ions, whatever it is. In order for this to be mixed, you have to overcome all those IMFs. So energy is consumed for both of those things, for overcoming the solute-solute, overcoming the solvent-solvent. And then the solute-solvent attractive forces will be established from there. So this has to release energy in order for this to happen. So one thing I do want to point out is not every time that you place, for example, a solid into, in other words, a solute into a solvent, doesn't always mean that the substance is dissolved, okay? In some case, it may be reacting. So for example, we have nickel metal, and hydrochloric acid. We place the nickel metal in the acid, and it looks like it just dissolved, right? But what actually happened is that you formed nickel chloride and H2 gas. So that solution is not just nickel dissolving into HCl, it's nickel chloride being formed. So that is the difference between, a chemical reaction versus just something dissolving and forming an aqueous solution. So this may be a term you've heard before, whether in this class or outside of this class, like dissolves like. This has to do whenever we are describing 2 substances that have very similar IMFs. They will be likely to be soluble in one another. So nonpolar solvents dissolve nonpolar solutes, polar solvents dissolve polar solutes, and also ionic solutes because of those electrostatic charges, the positive cations and the negative anions. So in organic chemistry, we use extraction, which is a technique that takes advantage of the differences in solubility, so miscibility. So in this technique, you will have a mixture. Now, in that mixture, there's something you want, and then there's things you want to get out of there. So you want to purify this solution and end up with a pure compound or a pure solvent, right? So what we're going to do is you are going to add an immiscible solvent, but what happens with that immiscible solvent is that your contaminants or whatever is making your solution not pure will dissolve in that. So you shake it really well. That contaminant ends up dissolving in that new solvent, you add it, and then now you have this clearer, and you don't have that contaminant in there. And then you will pour it out. So it's a special funnel that lets you shake, and then you can extract your either wanted solvent or the other solvent, whatever layer you want, but it lets you separate in that way. So this word you have probably also heard before, electrolytes. So either you heard it in Chem 1 or you hear it in daily life. I hear it a lot when people describe Gatorade or Powerade. They say, you know, Powerade has a lot of electrolytes. It helps hydrate you, right? For us, for humans, it's because we lose water, we lose ions, we need to replenish those, right? And if you heard me say ions, that is completely correct, and it also reflects what we're talking about here. So electrolytes are substances that dissolve in water and undergo a physical change or chemical change to produce ions. So strong electrolytes, 100% of it will be dissolved and generate ions. Weak electrolytes, only a small fraction will generate ions. Non-electrolytes, they'll dissolve, but they do not produce ions. Now, how does this reflect in terms of why it's even called electrolytes? So whenever you have ions in solution, you will generate electricity. That's where that comes from. So non-electrolytes, for example, ethanol, whenever you have it in solution, it's dissolved, that's fine. But if you try to generate electricity, you will see that it does not. Strong electrolytes will have a very high conductivity, so a lot of electricity, and then weak electrolytes will have, you know, a little bit of electricity conducted. So we have two different types of electrolytes, whether they be strong electrolytes, non-electrolytes, weak electrolytes. We first have ionic. So ionic are basically ionic compounds. So whenever you dissolve ionic compounds in water, you actually have something occur called dissociation. Now, what this means is that when you throw that ionic compound into water, the two ions making that ionic compound will dissociate. They break apart. So, for example, when you have NaCl and you put it in water, the two ions, and in this case it's actually KCl, sorry, the two ions will dissociate into separate ions, and then water begins to surround those ions and solvate them. And the attractions that form between the water molecules and the ions is called ion-dipole attraction. What I imagine this process occurring, you know, in water, what it looks like to me, the solvation, right, the water is surrounding the ions, is whenever Mr. Krabs, whenever I forgot the details of this episode, whenever they're selling Pretty Patties and, you know, people go crazy about them and then they surround them to try to buy them, either SpongeBob or Mr. Krabs. We also have covalent electrolytes. So covalent electrolytes are basically, you know, molecular compound electrolytes. Now, whenever these react with water, or are in water, I should say, they don't dissociate. They do something called ionization. And again, this is actually from chapter, I believe, 4, Chem 1. But they react with water to produce ions, and that's what we call ionization. So, for example, here we have HCl. It's in water now, right? And what ends up happening is it reacts. So this is what that arrow is about. It's reacting with it. And you don't have to get caught up in all those details. Just look at what you get for the products. You get an ion. So this is what we mean by ionization, where we have molecular compounds such as this one reacting with water and getting an ion. So solubility, what is this term? and this term is important for all the different types of solutions that we can have: gases in liquids, solids in liquids, liquids in liquids, whatever it is. So solubility is the maximum amount of solute that can dissolve in a solvent at a given temperature. So I want you to think of how if you increase the temperature of water, you can probably add in more sugar, right? So tea will probably be able to dissolve more sugar than very cold water. Saturated solutions have that amount of solute dissolved, so just the perfect amount. Unsaturated solutions have less than the maximum amount. We also have something called a supersaturated solution, which we will discuss later on. So, like I stated, temperature can affect solubility. So, in addition to temperature, we talked about temperature, the nature of the solvent and solute molecules will also affect solubility. And then finally, when we have a gaseous solute, the pressure will also affect solubility.